Welcome back after this commercial break. Just kidding. Just like a cooking show, right? Commercial break, and then magically we're on to the next phase. So now 15 minutes have passed. So take a look here now at the cells. All right, that's what they look like, and I am going to take them out now. All right, so I want to see that. So take out the cells. I'm going to just put them in here, so they're safe in here. And now you can see something has happened. So what we are pretending here is, either way we can pretend here, that either that, we have our cell here, so we have a white part around the edges as you can see. So we can pretend that either the pink is waste and it needs to come out, or we can do it the other way, that the white is nutrients coming into the cell. So it can work either way, so just keep that in mind. So what we're going to do now is we're going to look at the diffusion. Okay, how much has it diffused? So I'm going to take my, so actually I'm going to put it on here. Now my hands are not. Diffusion, and that's going to be in millimeters. I'll hold that up later too. Okay, I'm going to try to get a whiteboard too. So I'm going to measure here in millimeters. So this is about 2 millimeters. And we do the other cube here, the middle cube. And it's about 2 millimeters. And the larger one here, also about 2 millimeters. Real quick, you're going to put the towel so I'm not slimy. Okay, so the diffusion for all the cubes. Okay, so it's 2 millimeters, 2 millimeters, 2 millimeters. Okay, I'll hold this out too so you guys can see here. All right, so the diffusion distance, this is distance, right? Distance is 2 millimeters for all the cubes. So what does that tell you about the rate of diffusion? So keep that in mind, the rate of diffusion. So that was 15 minutes. So time was 15 minutes. All right, so we have 2 millimeters of diffusion in 15 minutes. So therefore you should be able to calculate the rate of diffusion. Just like you calculate, miles per hour or any other kind of measurement like that, right? So that's the diffusion rate. Okay, so now keep in mind here that we need to calculate, and you have on the lab packet, it says surface area. For those of you who don't remember math, a cube has 6 sides to it. So if we just go with the little one who says 1, right? So we have a 1, that's easy, right? So a cube, so to calculate the surface area, we're going to calculate the surface area of each side. So that'll be 1 by 1, right? So each side would be 6 cubic centimeters. And therefore we have 6 sides, so that would be 6 cubic centimeters. That is the surface area. Now volume, you guys remember volume? That is height, length, and width. So for the cube here, that would be 1 times 1 times 1. So I'll just do this one calculation for you, then you guys can do the rest. So in your graphs, you're going to calculate surface area over volume. So the surface area over volume. So in this case, the surface area for the small cube was 6 centimeters. And that's area. And then the volume was 1 centimeter cubed. So you can calculate that, right? So this is what we have for cube 1. And then you can do the same thing for the other 2 cubes. And you should be able to answer all the questions in that lab packet. And if you do have questions, we'll talk about this in the class too. But I think I will just log on to Canvas on Thursday. And I'll let you know in the class when I'm going to log on in case there are like live questions. But you should be able to figure this all out. And then the ultimate objective of this lab is to figure out, if you were a cell, would you want to be the bigger cell or the smaller cell? What is going to be the most efficient cell? Okay, good luck with everything. All right, bye you guys.